In today's video, we'll be exploring the concept of functions and relations. Now, all the questions that we'll be solving today were all retrieved from the most recent CSEC past papers. If you're new to this channel, please take this time out to subscribe and hit that notification bell to be notified whenever we post new videos. Alright, so these are the questions that we'll be looking at today that you're currently seeing on screen. So today we'll be looking at 3 questions. Alright, so we're looking at the problem that was given on the June 2018 paper, the June 2019 paper, and the January 2020 paper. Alright, and hopefully that will help you guys to be better able to approach any function and relation problem that you'll come up against. Alright, now if you're not comfortable with this concept, I've already created a video demonstrating and teaching that concept from the basic sense. So if you want to learn that concept, I'll have the video of that titled Easiest Way to Learn Functions and Relations in the description below. Alright, I'll also have a video on integers down there, so if you want to learn integers, you can also check the description section below. Alright, as well as I have a playlist on the fundamentals of mathematics. So if you want to learn the fundamentals, that will help you to better able to approach other concepts, then you can also check the description below for that as well. Alright, now let's get right into this thing. Alright, and the thing that what you guys can always do, you can always pause the video, attempt the questions that you were seeing on screen, and then resume the video. Alright, and then watch and see the correct solutions. Alright, so the first question, alright, so the function f with domain A is 1, 2, 3 is given by f of x is equal to 1 over 2 times x minus 3. Alright, and this is actually a 4-part question. Alright, so we'll be looking at them individually. Now the first part of the question asks us what is the value of f of 1. Alright, which is pretty easy. Alright, so all this requires us to do is to actually substitute 1 in the function f of x is equal to 1 over 2 times x minus 3. Alright, so let's do that. Alright, so here we have the function f of x being equal to 1 over 2 times x minus 3. Alright, and before I actually substitute 1 into this thing, another way how we can rewrite this function, 1 over 2 times x, we can also rewrite this thing as f of x is equal to x over 2 minus 3. Alright, I guess this is nicer to look at, so you can always do that. Alright, now what we're going to do now is to substitute 1 in this thing. So wherever we have x, we'll replace that with 1. So if we want to find f of 1, wherever we have the x, we'll replace the x with 1. So we'll have 1 over 2 minus 3. Alright, and we can now solve this thing using the fractional method. So we can put this thing over 1, find the LCM. Now what's the LCM for 2 and 1? Of course, that's 2. Alright, so 2 is the lowest number that both 2 and 1 can go into without leaving a remainder. So 2 into 1 goes 1 times. 1 times 1, that's 1, minus 1 into 2 goes 2 times. 2 times 3, that's 6. And here we have a little integer concept going on here. So this will give us negative 5 over 2. And again, if you want to learn this concept of integers, I have a detailed lesson of that on YouTube. So you can check the description section below titled Easiest Way to Learn Integers if you want to learn all about that. Alright, and we can also rewrite this thing as a mixed fraction. So negative 5 over 2 is the same thing as negative 2 and a half. Alright, so 2 going to negative 5, negative 2 times remainder 1 over 2. Alright, so that's how you treat with the first part of the question. So that's how we would have find what is the value of f of x. Alright, so that's how we treat with that part of the question. All right, so here we have part 2 of the question. So this asks us to find the value of x for which f of x is equal to -2, all right? And again, we want to recall the function. So remember the function f of x is equal to 1 over 2 times x minus 3, all right? And again, as I explained before, we can rewrite this thing as f of x is equal to x over 2 minus 3, all right? And here they're telling us that f of x, we want to find the values of x when f of x is equal to -2, all right? So if f of x is equal to x over 2 minus 3 and f of x is equal to -2, we can set this thing up. Then x over 2 minus 3 must be equal to -2, all right? Hope that makes a lot of sense to you. If not, I'm going to demonstrate a little thing right here to help you better understand what took place there, right? So let's say we have 3 being equal to 2 plus 1 and 3 being equal to 3 times 1, all right? Now if 3 is equal to 2 plus 1 and 3 is also equal to 3 times 1, then it must be true that 2 plus 1 is equal to 3 times 1, all right? Because 2 plus 1 is the same thing as 3, and 3 times 1 is the same thing as 3. So this would be balanced, all right? So if f of x is equal to x over 2 minus 3, and f of x is equal to -2, then x over 2 minus 3 must be equal to -2, all right? So hopefully that makes a lot more sense now, all right? Now what we can do now is to transpose this thing for x. So I want to make x the subject because this asks us to find the value of x, all right? So I want to make x the subject. That simply means we want x on one side of the equal sign by itself. So we need to transpose this thing. And the key thing about transposition, when you're transposing and you want to get rid of something, you simply do the opposite of the operation that is taking place, all right? And whatever you do on one side, you want to do the same thing on the other side to keep the equation balanced, which is very important, all right? So first thing first, we want to get rid of this -3. To get rid of the -3, we must do the opposite of the operation that is taking place. So if we want to get rid of a -3, we'll have to do the opposite, which is to add 3. If we add 3 on that side, we're required to add 3 on that side also, all right, to keep the equation balanced. Now, -3 plus 3, those things cancel. So we're left with x over 2 being equal to +1. All right. And we can put this thing over 1. So 1 is the same thing as 1 over 1. And now we can cross multiply. All right. So x times 1 is x. 2 times 1 is 2. All right. So the value of x for which f of x is equal to -2 would have been x is equal to 2, all right? And that's pretty much how we treat with this aspect of the questions, all right? Quite easy. Now let's look at part 3 of the question. An ordered pair for the function is expressed in the form a, comma b in parentheses, and this is how we write ordered pair. The a refer to the x value and the b refer to the f of x value, which is the same thing as y. All right. Using your answers to part 1 and part 2, or otherwise list the ordered pairs for the function f. All right. So what I want to do is to first remember the answers that we would have got in part 1 and part 2. So in part 1, we got f of 1 to give us -5 over 2. And in part 2, when f of x is equal to -2, our x value was 2, all right? So here, this one will actually represent our x value, all right, which is the domain. So x is equal to 1. So when x is equal to 1, f of x is equal to -5 over 2. So this is in part 1. In part 2, so when x is equal to 2, our f of x is -2. All right. Now, I wanted to recall the original question. So this is what I'm showing you now. So recall the original question. the function f with domain a is equal to 1, 2, 3. So we would have already obtained our f of x when x is equal to 2 and when x is equal to 1, all right? But remember, the domain was what? 1, 2, and 3. So we need to find our f of x when x is equal to 3, all right? So this is the domain of the function 1, 2, and 3. Domain pretty much refers to the x values, all right? So we need to find what f of 3 is, and then we can write out all the ordered pairs for this function, all right? So how do we actually go about finding f of 3? So again, what we want to do is to recall the f of x function, which is f of x is equal to 1 over 2 times x minus 3. And remember, as I outlined previously, we can rewrite this thing as f of x is equal to x over 2 minus 3, all right? So what we want to do now is to actually substitute 3 in this function, all right? So to find f of 3, wherever we have x, we'll replace the x with 3. So x over 2, we'll replace the x with 3. So this will become 3 over 2 minus 3. And again, with 3 is the same thing as 3 over 1. We can find the LCM and solve this thing, all right? So the LCM for 2 and 1 would have been 2. 2 into 2 goes 1 times. 1 times 3, that's 3, minus 1 into 2 goes 2 times. 2 times 3, that's 6. 3 minus 6, that's negative 3 over 2, all right? And that's how we would have find our f of 3, all right? So when we sub 3 into this thing, 3 actually represents our x. If you notice, we actually replace the x with 3, all right? So that simply means x would have been equal to 3. So we can say now that when x is equal to 3, our f of x is equal to this right here, which is negative 3 over 2, all right? So we can now write our ordered pairs for this function, all right? So these would have been our ordered pairs. And how do we write an ordered pair? Now this is how we write the ordered pair. So we would have x, comma, and the f of x value, all right? So we actually can obtain 3 ordered pairs from this thing, which is quite easy, all right? So our ordered pairs, I'm going to write ordered pairs here. So these would have been our ordered pairs. So let's look at the first one. We'll have x first. So remember, this is how you write the ordered pairs, the x value first, then the f of x. So my x value is 1. So I'll have the 1 here, comma, then the corresponding f of x value, which would have been negative 5 over 2. All right, close bracket. So this is one ordered pair. The next one would have been what? When x is 2 and the x comes first, then the f of x value, which would have been negative 2. All right. And then I'll put the next one down here. So for this one, when x is 3, my f of x value is actually negative 3 over 2. All right. And these would have been our answer. So we have one ordered pair being 1 and negative 5 over 2 in bracket, 2 and negative 2, 3 and 3 over negative 3 over 2, all right? So these would have been our ordered pair. So this would have been the solution for the question, all right, right there. So that is how you treat with this part of the question. All right, so let's look at part 4 of this question, all right, which is the final part of the question. So this asks us to explain why f of x is not equal to 5 for the function specified, all right? So I want you to recall the original information or data that was given concerning the question, all right? So remember this thing right here. So this outlined that what? The function f with domain, and it outlined the set with the domain A, set A is equal to 1, 2, and 3. And remember, the domain refers to all the x values, all right? So according to this function, x can only be 1, 2, or 3, all right? So the set A describes the domain, so 1, 2, or 3. So if we should allow the function of f of x to be equal to 5, and our x value is not 1, 2, or 3, then that pretty much we can conclude that, of course, f of x is not equal to 5, because according to this particular function, the only x values that are in the domain are 1, 2, and 3, all right? So let's look at that. So we're going to recall the function. So recall the function f of x is equal to 1 over 2 times x minus 3. And again, as outlined previously, this is the same thing as x over 2 minus 3, all right? And we're also going to want to see what happens when f of x is equal to 5, all right? Let's see the x value that we get. And again, if f of x is equal to x over 2 minus 3 and f of x is equal to 5, then we can say x over 2 minus 3 is equal to 5, all right? And we can now transpose this thing, all right? So we're going to transpose this thing for x. So again, the key thing about transposition, to get rid of something, you are going to do the opposite of the operation that is taking place, all right? And whatever you do to one side, you must do the same thing to the other side to keep the equation balanced, all right? So I want to get rid of this negative 3 first. To do that, we must do the opposite, which is to add 3. And if we add 3 on that side, we're required to add 3 on this side also, all right? So negative 3 plus 3, those things cancel, and we're left with x over 2 is equal to 5 plus 3, that's 8, all right? And again, we can put the 8 over 1 and cross multiply. So x times 1 is x. All right, ensure that is on screen. So that's x is equal to 2 times 8. That's 16, all right? So here we actually obtain x to be 16. And remember, the x values actually give me the domain, all right? So that's the key thing. So the only domains that are in this function, which is the set A, are 1, 2, and 3, all right? So this alone let me know that what? There's no way that f of x can be equal to 5, because if f of x is equal to 5, then I'm getting x to be 16, and this is not a part of the domain. The only values that are a part of the domain are actually what? 1, 2, and 3, all right? And all of this is a set A, all right? So we can say the set A, which is equal to 1, 2, and 3, all right, does not contain 16 according to the data given, all right, given, thus f of x is not equal to 5, all right? So I hope that makes a lot of sense. So this would have been our explanation. So you'll carry out the calculation to prove all of that, and then you can give this explanation down here to get the full marks, all right? So that's how we treat with the June 2018 paper. All right, now I want to look at the June 2019 paper and see how we solve those questions. Now let's look at the June 2019 paper, all right? So the functions f and g are defined by f of x is equal to 9 over 2x plus 1 and g of x is equal to x minus 3, all right? Now the first part of the question asks us to state a value of x that cannot, all right, very important, that cannot be in the domain of f, all right? So f let us know that of the function that we should be looking at, all right, which is f of x is equal to 9 over 2x plus 1, all right? So we want to state a value of x that cannot be in the domain of the function, all right? Now, what we know is that if we have 9 over 0, then that is infinity, all right? So we don't want to have something like this. We don't want to have f of x being equal to 9 over 0, all right? So if we want to state a value of f of x that cannot be in the domain of f, we want to know the value of x that if we place that value for x right here, then we'll get the denominator to be equal to 0. So how we actually go about solving this thing? What we're going to do, we're going to equate the denominator to 0, all right? And solve it, all right? And that's how we'll obtain that value that cannot be in the domain of f, all right? So again, we can transpose this thing, and when we are transposing, we'll do the opposite of the operation that is taking place to remove something, and whatever we do on one side, we must do the same thing to the other side. All right. So what we're going to do now, we want to get rid of this positive one first. So we must do the opposite, which is to minus 1. And if we minus 1 on that side, we're required to minus 1 on that side as well. So we have 1 minus 1. Those things cancel. We're left with what? We're left with 2x. Ensure that's on screen. We're left with 2x is equal to 0 minus 1. That's minus 1. And what we're going to do now, because we have 2 times x, we're going to do the opposite of that, which is to divide. Opposite of multiplication is division. So, and we have to divide both sides, all right, to keep the equation balanced. So 2 cancel 2 here, and we're getting x is equal to negative 1 over 2, all right? So this would be the value of x that cannot be in the domain of f, all right? And we can write a statement about that, all right? So we can say, so x is equal to negative 1 over 2 cannot be in the domain of f of x, all right? Because if that happens, we can say what? We say that f of x is undefined all of that on screen. Undefined for x equal negative 1 over 2, all right? And that pretty much covers part 1 of this thing, all right? So that is how we treat with part 1. So we actually demonstrated how we actually go about finding the value of x that cannot be in the domain. And we just wrote a statement here to give clarity to what we would have done up here, all right? Just to ensure that we get that distinction in math, all right? So what we're going to do now is to look at part 2. All right, so let's look at part 2. So this asks us to find, in its simplest form, expression for f of g of x. And again, this is a 2-part question, so we have A and B. But let's look at A first, all right? So this wants us to find f of g of x, all right? And this is composite functions. And again, if you want to learn about that, you want to check out that video in the description section below that is titled Easiest Way to Learn Functions and Relations, all right? So this thing is explained in detail in that video that I won't do in this video, all right? So you want to check out that video if you don't understand what this thing is all about. Now, what we want to do is to recall the function. So remember, f of x is equal to 9 over 2x plus 1, and g of x is equal to x minus 3, right? So these were the functions that we got in the question, all right? If you don't remember, you can always rewind this video a little bit and check that out, and then come back to this stage of the video if you so choose to, all right? So if we want to find f of g of x, what this simply means, we're going to substitute the g of x function into the f of x function. So wherever we have x, we'll replace the x with the function for g of x, which is x minus 3, all right? So replace this x with x minus 3. So let's see how we actually go about doing that. So here we have f of g of x would be equal to, I have the 9 over 2, where I have the x now, I'm going to replace the x with this function right here, the entire thing, which is x minus 3 plus 1. So I write back the plus 1 there. So again, I replace the x right here with the entire function of the g of x function. So x minus 3, place the x with x minus 3, then I wrote back the plus 1 right here, right? So hopefully that's clear. And they ask us to write this thing in its simplest form, all right? So we can leave it like that. So we'll have 9 over, we can expand the bracket. So 2 times x, that's 2x 2 times negative 3, that's negative 6. And then we have the 1 out here, plus 1. And we can still simplify this some more. So this is the same thing as 9 over 2x. Negative 6 plus 1, that's negative 5. All right. So that's the answer. So we can say, therefore, f of g of x is equal to 9 over 2x minus 5. And this would be, ensure that's on screen. So this would be the solution for part 2, all right? So that's how you go about it. Quite easy, all right? So nothing difficult here. All right, so let's look at part B. So part B asks us to find f inverse of x, all right? So what we want to do first, again, is to recall the f of x function, which was what? 9 over 2x plus 1. And what we can do now is to go about finding the inverse of this thing. So the first step, we're going to let f of x be equal to y. So I replace the f of x with y. So y is equal to 9 over 2x plus 1. What we're going to do now is to interchange x and y. So wherever I have y, I'm going to replace y with x. Wherever I have x, I'm going to replace the x with y, all right? So here I have the y, I'm going to replace that with x, is equal to 9 over 2. And again, I'm going to replace the x with y plus 1, all right? What I'm going to do now is to make y the subject. So once I obtain y or get y to be the subject, then I would have obtained the inverse for this particular function, all right? So I want to make y the subject. I'm going to keep this thing in bracket because I'm going to put the x over 1 and I'm going to cross multiply. So it's always safe to keep this expression in bracket. All right, so if I do that, I'm going to end up with x times the bracket here, which is 2y plus 1 is equal to 9, all right? And what I'm going to do now, I'm going to expand this bracket right here. So x times 2y, I'll get 2xy plus x times 1, that's x. And this is equal to 9, all right? What I'm going to actually do now is to get rid of this positive x over here. So I'm going to minus x from both sides. So I'm going to end up with 2xy plus x. Going to minus x over here. Must do the same thing over here as well. X cancel, negative x there. And I'm left with 2xy is equal to 9 minus x, all right? Now I want to make y the subject of this thing right here, all right? The subject of the equation. So what I'm going to do now is to divide both sides by 2x, all right? So 2x cancels 2x, so I'm left with y is equal to 9 minus x over 2x, all right? So therefore, I can say the inverse of f of x is equal to 9 minus x over 2x, all right? So this would actually be the inverse for this particular function. And that's pretty much how we treat with the function question that was given on the June 2019 paper, right? So now let's look at the final paper, which is the January 2020 paper. Now let's look at the January 2020 paper, all right? So the function f is defined as f of x is equal to 2x plus 7 over 5. Now this is also a two-part question, and just like the initial question or the question before this one, it has both a part A and a part B to it, alright? And we'll look at those when we get to that. Now the first part of this question asks us to find the value of f of 4 plus f of negative 4. This is pretty easy actually, right? So what we're going to do, we're going to sub 4 into this thing, and we're also going to sub negative 4. The result that we'll obtain when we sub 4 into this thing, we'll add that to the result that we'll obtain when we sub negative 4 into that, all right? Let's actually carry out this thing now. So remember the function. So this is the function that we're dealing with. So we want to sub 4 into the function. If we sub 4 into the function, we're going to, wherever we have x, we'll replace the x with 4, all right? So this is the same thing as 2. We have the 4 here. All right, so I replace the x with 4, put that in bracket, plus 7 over 5. All right. And what do I get when I do this? So this is the same thing as 2 times 4, that's 8. So I have 8 plus 7 over 5. All right. What's 8 plus 7? 8 plus 7 gives us 15, all right? So this is 15 over 5, which is 3, all right? Now what we are going to do, we are going to sub the negative 4 now into the same function. So wherever we have x, we'll replace the x with negative 4. So we'll have 2 and negative 4 in bracket plus 7 over the 5 down here, all right? And again, this is the same thing as 2 times negative 4. That's negative 8 plus 7 over the 5 down here. And this is equal to negative 8 plus 7. That's negative 1 over 5, all right? So what we're going to do now, they want us to do what? Add f of 4 plus f of negative 4. So the value that we got for f of 4 was what? 3. And the value that we obtained for f of negative 4 was negative 1 over 5, all right? So what we're going to do now is to actually add those results. So if we want to add f of 4 plus f of negative 4, we're going to add 3 plus negative 1 over 5, all right? So that's pretty much what they're asking us to do, all right? So how do we go about this thing? Now remember, a positive and a negative sign beside each other like this is the same thing as a negative sign. So this is the same thing as 3 minus 1 over 5. And again, if you're not comfortable with integers, you really want to check out that video that I have in the description below, right? It's titled The Easiest Way to Learn Integers, and it's pretty much the easiest way to learn integers. So you want to check that video out. Now, this 3 here, I can rewrite this thing as 3 over 1, and we can find the LCM for this thing, all right? So LCM for 1 and 5, of course, that's 5. That's the smallest number that both 1 and 5 can go into without leaving a remainder. 1 into 5 goes 5 times. 5 times 3, that's 15, minus 5 into 5 goes 1 times. 1 times 1, that's 1, all right? If we simplify this thing, 15 minus 1, that's 14 over 5. Or we could write this thing as what? 2 and 4 over 5, all right? So this would actually be our result, all right? So we can say therefore f of 4 plus f of negative 4 is equal to 2 and 4 over 5, all right? So this would actually be our answer for part 1, all right? Let's look at part 2. So this asks us to calculate the value of x for which f of x is equal to 9. Now what we want to do first now is to actually recall the function, all right? So the function outlined that what? F of x is equal to 2x plus 7 over 5, all right? So they want us to actually deduce the value of x for which f of x is equal to 9. And again, just like the previous question, if f of x is equal to 2x plus 7 over 5 and f of x is equal to 9, then of course 2x plus 7 over 5 must be equal to 9, all right? And we can now simplify this thing or transpose this thing to obtain or ascertain the value of x, all right? Now, 9 is the same thing as 9 over 1. I'm going to put this expression, which is the numerator, in bracket, and we can cross multiply. So we'll have the entire bracket times 1. 1 times anything remain the thing. So we'll end up with the bracket on one side, which is 2x plus 7 is equal to 5 times 9, which is 45. All right. Now we want to get rid of the 7. And again, when we are transposing, we do the opposite of the operation that is taking place to remove something, all right? And whatever we do to one side, we must do the same thing to the other side, all right? So what we want to do now is to remove this positive 7. So we'll be required to do the opposite of that, which is minus 7. So minus 7 on that side, we're required to minus 7 on this side also. 7 minus 7, these things cancel. We're left with 2x is equal to 45 minus 7, that's 38. And here we have 2 times x is equal to 38. To get rid of this 2, we must do the opposite of the operation that is taking place. And this is multiplication, so we do the opposite, which is division. And if we divide that side by 2, we must do the same thing to the other side to keep the equation balanced. So 2 cancel 2, and x is equal to 19. All right. So that's how we treat with this part of the question. So our x value would be equal to 19. All right. Now let's look at the other part of the question. So this would have been part A. All right. All right. So now let's look at part B, which is the final part of this question and the final question that we'll be looking at today. All right. So hence or otherwise determine the value of f inverse of 9. All right. So f inverse of 9. So once I outline, hence that pretty much means that there is a possibility that we could use what we would have obtained up here to actually deduce the value of f inverse of 9. All right. Now remember, when we subbed, so if we actually sub x equal 19 into the f of x function, we'll obtain f of x to be equal to 9. All right. And remember, the inverse of a function does the opposite of the function. All right. So if x equal 19 would be mapped to f of x is equal to 9, then the inverse of this thing would be the opposite. All right. So the other way around. So the inverse f inverse of 9, the result that we'll obtain would actually be 19. All right. So this is one way how we could actually do it, or we can actually find the inverse of this function right here, which is f of x equal to x plus 7 over 5, and then substitute 9 into that function to obtain the value. All right. But this is the easier way to do it. However, I'm also going to demonstrate how to do this by finding the inverse of this function and then substituting the value of 9 into the function. All right. And if you don't understand what inverse and all of this is all about, then I implore you to watch the function video that I have in the description section below. All right. So as I outlined previously, the inverse, f inverse of 9 would give us 19. All right. Based on what I just explained before, because the inverse of a function does the opposite of the original function. All right. Now I'm going to demonstrate the alternative route of doing this. All right. So that they also mentioned that here that we could hence use what we would have obtained previously or otherwise. All right. So I'm going to look at the alternative method. All right. So now let's look at the alternative method. So this is another way how we could obtain f inverse of 9. All right. So look at the alternative method. Now what we want to do is to actually recall the function. All right. Recall the original function. So remember, f of x is equal to 2x plus 7 over 5. All right. So what we want to do is to find the inverse of this function, then substitute the value of 9 into the function, and whatever result we get, then that will actually be our answer. All right. So how do we find the inverse of this thing? So again, we're going to let f of x be equal to y. All right. So y is equal to 2x plus 7 over 5. Then what we're going to do now is to interchange x and y. So wherever I have y, I'm going to replace the y with x. Wherever I have x, I'm going to replace the x with y. So here I replace the y with x. Now I'm going to replace the x with y. So 7 over 5. All right. So all I did there was to interchange x and y. So I replaced the y with x and the x with y. All right. Now what I'm going to do now is to actually make y the subject of this equation. All right. And once I make y the subject, then that would actually give me the inverse of this function. All right. So I can put x over 1 and then cross multiply, all right? And again, I can put this thing in bracket. I don't have to, being that we have 1 over here, but I'm going to do it just the same, all right? So here we'll have 1 times the bracket and 1 times anything, remain the thing. So this will be 2y plus 7 is equal to 5 times x, which is 5x, all right? Now what I'm going to do is to get rid of this positive 7. And again, as I mentioned previously, moreover, when we are transposing, we do the opposite of the operation that is taking place, all right? So to get rid of this positive 7, we do the opposite of that, which is to minus 7, all right? And whatever we do on one side, we must do the same thing on the other side to keep the equation balanced. So 7, so cancel this minus 7 here, and we'll be left with 2y being equal to 5x minus 7, all right? What I'm going to do now is to divide both sides by 2 to make y the subject, because here I have 2 times y. So to get rid of the 2, I'm going to do the opposite of that operation, which is to divide by 2. Whatever I do to one side, I must do the same thing to the other side. So 2 cancel 2, so y is equal to 5x minus 7 over 2, all right? So therefore, this actually gives me my inverse. So f inverse of x would be this function right here, 5x minus 7 over 2. And remember what I'm trying to find. I'm actually trying to find f inverse of 9, all right? So wherever I have x, I'm going to substitute 9 right there. So if I want to find f inverse of 9, wherever I have x, I'm going to replace the x with 9. So 5 in bracket, I'm going to put the 9 right there, minus 7 over 2, all right? What do I get when I simplify this thing? 5 times 9, that's what? 45 minus 7 over 2. 45 minus 7, that's 38 over 2. And 2 goes into 38 19 times, all right? So therefore, f inverse of 9 is actually 19, all right? So this is another way how you can actually find f inverse of 9, all right? Or you could do it the previous way that I outlined by using the concept that the inverse of a function does the opposite of the original function, all right? So you choose, all right? Good thing about maths, there are many ways to do the same thing, all right? So I hope this video helped you guys. All right, so that's where we'll end today's video. Don't forget to give this video a thumbs up, all right? And if you haven't yet done it, please subscribe to the channel. Until next time, as always, thanks for watching, all right?